Good morning, everyone. This is Sachin Fiske from Electrical Engineering Department, SND College of Engineering and Research Center. Today, we are discussing some points related to temperature sensor, a simple form of temperature sensor that can be used to provide an on-off signal when a particular temperature is reached is the bimetal element, and this consists of two strips of different metal such as brass and iron bounded together. It is shown in the side figure. The two metals have different coefficient of expansion. Thus, when the temperature of a bimetal strip increases, the strip curve in order that one of the metal can expand more than the other. The higher expansion metal is on the outside of the curve. As the strip cools, the bending element is reversed. This movement of the strip can be used to make or break electrical contact and hence at some particular temperature give an on-off current in the electrical circuit. The device is not very accurate but is commonly used in domestic central heating thermostat because it is a very simple, robust device. We all use temperature sensor in our daily life, be it in the form of thermometer, domestic water heater, microwave, or refrigerator. Usually, monitoring field being one of them. Temperature sensors are a simple instrument that measures the degree of the hotness or coolness and convert it into a readable unit. But have you ever wondered how the temperature of the soil, borewell, huge concrete dams, or building is measured? Well, this is accomplished through some of the specialized temperature sensors. The temperature sensors are designed to keep a regular check on concrete structure, bridge, railway track, soil, etc. Here, we are going to tell you what is the temperature sensor, how does it work, where is it used, and what are the different types. So what are the temperature sensor? A temperature sensor is a device, typically a thermocouple or resistance temperature detector that provides the temperature measurement in a readable form through an electrical signal. A thermometer is the most basic form of the temperature meter that is used to measure the degree of the hotness and coolness. Temperature meters are used in geotechnical field to monitor concrete structures, soil, water, bridges, etc. for structural changes in them due to seasonal variation. A thermocouple or TC is made from two dissimilar metal that generates an electric voltage in direct proportion with the change in the temperature. And RTD, that is resistor temperature detector, is a variable detector that changes its electrical resistance in the direct proportion with the change in the temperature in a precise, repeatable, and nearly linear manner. Now, what do temperature sensors? A temperature sensor is a device that is designed to measure the degree of hotness or coolness in an object. The working of a temperature meter depends upon the voltage across the diode. The temperature change is directly proportional to the diode resistance. The cooler the temperature, lesser will be the resistance, and vice versa. The resistance across the diode is measured and converted into readable unit of the temperature. For example, Fahrenheit, Celsius, or centigrade, and display in numeric form over the readout unit. In geotechnical monitoring field, these temperature sensors are used to measure the internal temperature of the structures like bridges, dam, building, power plant, etc. What is the temperature sensor used for, and what are the function of the temperature sensor? Let us see. Well, there are many types of temperature sensor, but the most common way to categorize them is based upon the modes of connection, which includes the contact and non-contact temperature sensor. Contact sensor includes thermocouple and thermistor because they are in direct contact with the object they are to measure, whereas the non-contact temperature sensor measures the thermal radiation released by the heat source. Such temperature meters are often used in hazardous environments like nuclear power plant or thermal power plant. In geotechnical monitoring, the temperature sensor measures the heat of hydration in mass concrete structure. They can also be used to monitor the migration of groundwater or seepage. One of the most common area where they are used is while curing the concrete because it has to be relatively warm in order to set and cure properly. The seasonal variation causes structural expansion or contraction, thereby changing its overall volume. How does the temperature sensor work? The basic principle of working of the temperature sensor is the voltage across the diode terminals. If the voltage increases, this temperature also rises, followed by a voltage drop between the transistor terminal or the base and emitter in the diode. And basically, this encardioid has a vibrating wire temperature sensor that works on the principle of stress change due to temperature change. The vibrating wire temperature meter is designed on the principle that dissimilar metals have a different linear coefficient of expansion with temperature variation. It primarily consists of a magnetic high tensile strength stretch wire, the two ends of which are fixed to any dissimilar metal in a manner that any change in the temperature directly affects the tension in the wire and thus its naturally frequency of vibration. The dissimilar metal in the case of the encardioid temperature meter is aluminum has aluminum, and as a temperature signal is converted into frequency, the same readout unit which is used for other vibrating wire sensors can also be used for monitoring the temperature also. The change in the temperature is sensed by a specially built encardioid vibration wire sensor and is converted to the electrical signal which is transmitted as a frequency to read out unit. The frequency which is proportional to the temperature and in turn to the tension sigma in the wire can be determined as frequency is equals to 1 by 2 into sigma j upon p upon 2 hertz, where this sigma is indicated as tension of the wire, g is acceleration due to gravity, rho is the density of wire, and L means length of the wire. So what are the different types of the temperature sensor? Basically, there are various types of the sensor available based on types and sizes. So two main types are contact type temperature sensor and non-contact type temperature sensor. Let us see. There are few temperature meter that measures the degree of hotness or coolness in an object by being in direct contact with it. Such temperature sensor falls under the category contact type, and they can be used to detect the soil, liquid or gases or a wide range of the temperature. This non-contact type temperature sensors. Such type of sensors or temperature meters are not in direct contact of the object. Rather, they measure the degree of the hotness or coolness through the radiation emitted by the heat source. The non-contact type temperature sensors are further divided into thermostat. A thermostat is a contact type temperature sensor consisting of a bimetallic strip made up of two dissimilar metals such as aluminum, copper, nickel, or tungsten. The difference in the coefficient of linear expansion of both the metal causes them to produce a mechanical bending movement when it is subjected to heat. Thermistor or thermally sensitive resistors are the one that changes their physical appearance when the subject to change in the temperature. The thermistor are made up of the ceramic materials such as oxide of nickel, manganese, or cobalt coated in a glass, which allows them to deform easily. And most of these thermistors have a negative temperature coefficient, that is anti-C, which measures their resistance decreases with an increase in the temperature. But there are few thermistors that have a positive temperature coefficient, that is PTC, and their resistance increases with a rise in the temperature. Now RTD. What is RTD? So RTD are the precise temperature sensor that are made up of high purity conducting metals such as platinum, copper, or nickel wound into a coil. The electrical resistance of an RTD changes similar to that of the thermistor. One of the most common temperature sensors includes the thermocouple because of their wide temperature operating ranges, reliability, accuracy, simplicity, and sensitivity. A thermocouple usually consists of two junctions of dissimilar metal, such as copper or constant, that are welded or crimped together. One of these junctions, known as a cold junction, is kept at a specific temperature, while the other one is a measuring junction, which is known as the hot junction. On being subjected to temperature, a voltage drop is developed across the junction, as shown in figure. Thank you.